Look up at the night sky, just after sunset or before dawn. Among the countless points of light, one often shines with a steady, brilliant gleam, outshining every star. It's not a star, but a world. We call it Venus. For millennia it has been a celestial constant, a familiar beacon known as both the morning star and the evening star. For centuries it captivated us. Ancient civilizations saw its serene beauty and named it for their goddesses of love, Aphrodite for the Greeks, Venus for the Romans. It was a jewel in the twilight, a beacon of the morning, a symbol of perfection in the heavens. The allure wasn't just poetic. As our scientific understanding grew, the similarities became uncanny. It's about the same size as Earth, a mere fraction smaller. It's a terrestrial planet made of roughly the same rock and metal and is our closest planetary neighbor. So naturally we imagined it as a kindred spirit, a twin to our own world. This idea of a twin Earth ignited our imagination. Science fiction writers dreamed of a younger, more primitive version of our world. They painted pictures of lush, tropical jungles drenched in constant rain, vast oceans, and maybe, just maybe, exotic life teeming beneath its perpetual cloud cover. It was a world of mystery and adventure, a new frontier waiting to be explored. This tantalizing veil of mystery made Venus an irresistible destination for the dawn of the space age. Telescopes, no matter how powerful, were useless. The planet's atmosphere is incredibly reflective, a brilliant, featureless shield that bounces sunlight back into space, hiding its face completely. What secrets were hidden beneath those brilliant white clouds? What was the true nature of our sister planet? The paradox was maddening. The similarities were striking, almost poetic. We could calculate its orbit, measure its diameter, and even estimate its mass. We knew its physical stats, but its surface remained a complete enigma, shrouded by an atmosphere that reflected sunlight with dazzling intensity. Was it a paradise? A younger Earth, perhaps still in its primordial, steamy youth? Or was it something else entirely? The questions piled up in scientific circles. What was the surface temperature? Was there liquid water? What was the atmospheric pressure? The answers were critical, not just for understanding Venus, but for understanding the potential destiny of Earth itself. Venus, our enigmatic neighbor, became a focal point of the burgeoning space race. It was the most tempting first step beyond the cradle of Earth. The desire to know what lay beneath that veil drove innovation and ambition. We painted pictures in our minds, filled in by the vastness of what we didn't know. Perhaps its oceans were warm and inviting. This sister planet held a mirror to our hopes and our curiosity. It was a blank canvas for our dreams of other worlds. But dreams are not data. Science needs evidence. The only way to get answers was to go there and pierce the clouds to see the truth. In the middle of the 20th century, two superpowers battled for supremacy. It was a conflict fought not with armies, but with ideology and innovation. This was the Cold War. In this high-stakes global chess match, the cosmos became the ultimate board. The competition reached into the heavens, the space race, a contest for technological and symbolic dominance. While the world's attention was captivated by the race to the moon, the Soviet Union fixed its gaze on a different, more enigmatic prize, Venus. Often called Earth's sister planet for its similar size and mass, its perpetual cloud cover sparked imaginations of a world beneath. Being first to land on another planet would be a monumental symbol of science and vision. To be the first to unveil the secrets of our mysterious twin was a prize of historic proportions. But the path to Venus was littered with failure. Early missions exploded on the launch pad or fell silent on the long journey through interplanetary space. Space is hard, interplanetary is harder. The vast distances amplified every risk. But for the Soviet program, setbacks were not deterrents, they were tuition. Each failure became a crucial lesson, each silent probe a data point in a brutal learning curve. They were in a race, determined to win. Out of this crucible, the Venera program emerged, an ambitious multi-decade endeavor. The challenges were immense. Early flyby missions had returned terrifying hints of the environment, but the full picture remained a mystery. Soviet engineers were designing a spacecraft for a place they'd never truly seen. You know it's hot, but how hot? You know there's an atmosphere, but how thick? The reward of discovery was worth every risk. The solution was a marvel of brute force engineering. The landers were tough and utilitarian, built like bank vaults. They had to survive being simultaneously melted, crushed, and corroded. The core was a spherical pressure vessel forged from titanium, the strongest shape to resist the immense external forces. This sphere was wrapped in layers of insulation and housed a pre-cooling system, chilling the probe before descent. They were, in essence, sophisticated fridges sent into a planetary-scale oven. descent systems were reinvented from heat shields to parachutes. Even camera windows needed specialized quartz and protective caps. Each mission improved on the last in a brutal, effective design loop. The descent was a trial by fire, slamming into the atmosphere at over 24,000 miles per hour. A red-hot shield guarded precious instruments within. In the soupy air, parachutes slowed the fall before a smaller drogue took over. Some missions even used a unique ring-shaped air brake. The long plunge grew hotter and heavier with every meter. Data poured back about the terrifying conditions, a crushing pressure 90 times that of Earth, and a lead-melting temperature of 462 degrees Celsius. Then, on October 22, 1975, Venera 9 reached the surface. The lens cap popped off. For the first time, we saw the surface of another planet. The images revealed a stark landscape of sharp, uneroded rocks. It was a stunning victory for the Soviets and for all humankind. Venera 9 transmitted for 53 precious minutes before the immense heat and pressure ended its voice. 3 days later, its twin, Venera 10, followed, surviving for 65 minutes. In those brief, fleeting windows, they opened a view into hell, transforming our understanding of Earth's sister from a potential paradise into a cautionary tale. Beyond the photos, the instruments told a far harsher story. As the Venera landers descended, the data they sent back was almost unbelievable. Temperatures soared and pressures mounted with every meter they fell. On the surface, the thermometer registered a staggering 465 degrees Celsius, hot enough to melt lead, zinc, and tin. This was a profound shock. Venus is nearly twice as far from the Sun as Mercury, yet its surface is significantly hotter. The planet was a furnace, but the heat wasn't just coming from the Sun, it was being trapped. And this heat was relentless. Data showed it was uniform across the entire planet, from the equator to the poles, through the long Venusian day and the equally long night. The culprit was a colossal atmospheric blanket composed of 96.5% carbon dioxide. Sunlight could pierce through the clouds and warm the ground, but when the surface radiated that heat back as infrared, the CO2 atmosphere wouldn't let it leave. This was humanity's first, terrifying, real-world lesson in the runaway greenhouse effect. While the atmosphere was a nightmare, the ground itself felt strangely familiar. Drills, designed to operate in the crushing heat for just a few minutes, bit into the surface. Spectrometers analyzed the soil, confirming it was basalt. This told us that Venus, like Earth and the Moon, was shaped by volcanism. The vast flat plains seen in the images were likely ancient lava flows. The surface pressure was measured at 92 times that of Earth's at sea level. To experience that on our own planet, you would have to dive nearly a full kilometer into the ocean, where the weight of the water above would be enough to crumple a military submarine. This immense pressure explained the fate of earlier failed probes. They weren't just malfunctioning, they were being instantly crushed by the sheer weight of the sky. The Soviet engineers' solution was both elegant and robust, a spherical lander. Built from thick titanium and packed with cooling systems, this shape distributes external pressure evenly, giving the delicate instruments inside a chance to survive, even for a few precious minutes. On the surface, the air is so dense it behaves more like a fluid than a gas. The recorded wind speeds were slow, only a few kilometers per hour, but in that super thick atmosphere, even a gentle breeze would feel like a persistent current pushing against you. The data pointed to a tragic history. Scientists now believe that long ago, Venus may have been a temperate world with shallow oceans. But as the young sun grew hotter, those oceans began to evaporate. Water vapor, a potent greenhouse gas, trapped more heat, which caused more evaporation. This feedback loop ran away, boiling the oceans into the atmosphere, and baking carbon dioxide out of the planet's rocks, sealing the world in a permanent planetary-scale furnace. High above, the planet is shrouded in clouds of concentrated sulfuric acid. From these clouds, a corrosive rain falls, but the surface is so hot that the acid droplets evaporate tens of kilometers before ever reaching the ground, creating a volatile cycle of corrosive chemistry in the middle atmosphere. Venus is a natural laboratory for climate dynamics, and a stark cautionary tale for our own world. Yet amidst this hellscape, Venera 13 and 14 sent back the first color photographs from the surface. The images revealed a world bathed in a dim orange light, filtered through the thick clouds. And there, in the foreground of these alien panoramas, lay a discarded lens cap and a color calibration chart, human artifacts resting on the ground of another world. The Venera program was a stunning success. The The first atmospheric entry, the first soft landing, the first images and even the first sounds ever recorded on another planet. It fundamentally rewrote planetary science, introducing concepts like the runaway greenhouse effect and revealing the bizarre super-rotation of the atmosphere. More than that, it taught us how to build for extremes, knowledge foundational for future missions to Jupiter's depths or Titan's lakes. Today, a new generation of missions like NASA's Veritas and ESA's Envision are preparing to return. They will carry advanced radar to map the surface in stunning detail, peer through the clouds to search for active volcanoes, and analyze the planet's internal structure. They aim to answer the questions Venera first posed. Is Venus still geologically active? What happened to its water? And how did Earth's twin suffer such a different fate? Venus still holds many secrets, and the bold spirit of Venera will guide us as we unveil them.